Hello everyone, and welcome to the UPCAST Data Integration and Exchange plugin webinar. My name is Jaime Salas, and I'm a research fellow at the University of Southampton, and I'll be guiding you through the UPCAST Data Integration and Exchange plugin and how to use it. To give a bit of context, UPCAST is a project that provides a suite of universal platform components for safe, fair, interoperable data exchange, monetization, and trading. Our consortium is comprised by 16 partners from 9 European countries, from both the industry and academic domains. Our mission is to support the deployment of common European data spaces, and our goal is to automate data sharing and processing agreements. I'll begin by outlining the agenda for this presentation. First, we'll begin by explaining why this topic matters for SMEs. Then, we'll introduce and explain some key concepts necessary to understand the plugin. Following this, we'll provide an overall analysis of the plugin, then a live demo showing our graphical interface. Finally, we'll highlight the key takeaways of this presentation and show some further readings and resources for those interested. Data is valuable and diverse. There are a vast number of resources available to gather data from. However, this data is rarely usable as it is and may need various processing steps to make it usable, depending on the application. Extracting useful data is not straightforward, because data may be unstructured or structured in different ways that will require specific querying systems. There are no one-fits-all systems. Various tools exist, but they may require additional expertise and knowledge from domain experts. Therefore, at UPCAST, we have addressed each of these issues by, first, providing a central language to define mapping rules from sources in different standard formats, such as CSV and TSV for tabular data, and JSON, XML, and RDF for semi-structured data. Second, by providing both command line and graphical interfaces to streamline the entire data integration process to aid domain experts. And lastly, by compiling the various systems and solutions into a unified system and providing tools to translate between different systems and standard formats. In a typical data integration scenario, a user would need, first, a source schema that defines the structure of their sources, such as RDF or CSV. Second, a target or global schema, which defines the structure of the target dataset. Third, mapping functions, which transform elements from sources to elements in the target schema. And finally, target or ontology dependencies, which describe relations between values and attributes in the target dataset, which may lead to additional data. The UPCAST Data Integration Manager is a framework that combines both forward and backward chaining approaches to provide the best of both worlds, featuring algorithms, implementations, and systems in an end-to-end approach to forward or backward chaining. Our framework identifies and packages several systems featuring writers, translators, parsers, and integration code to combine and seamlessly transfer between implementations. By providing a unified framework, we may leverage the system's strengths while avoiding their weaknesses by mixing and matching the optimal systems for each task. Furthermore, we make it easier on the user to answer a query by combining algorithms from both approaches. In order to achieve this, the plugin has this architecture and components. First, it contains a suite of parsing tools that interpret all relevant formats such as CSV for tabular data, RDF for graph data, OWL for ontologies, etc. This is then complemented with translators that can convert to and from different structures. For example, translate SQL queries to Sparkle queries to Datalog programs or vice versa. The next components are tasked with the actual data integration part of the system. The first of these components is the backward chaining system, which contains the state-of-the-art technologies that rewrite queries, either in Sparkle or SQL, according to ontologies and yield answers. On the other hand, we have the forward chaining system, which has additional reasoning systems that take ontologies and data sources to compute new facts in an integrated knowledge graph. Both systems then depend on an interpreter system that parses R2RML or RML files and translates them into instructions for the appropriate system. Instead of spending resources in learning different languages and systems, you can express your mapping rules in a single language, RML, and leverage our unified system that implements state-of-the-art solutions. In RML, data sources are expressed as logical sources, which are comprised of, first, a source, which may be an internal reference to a local file, or an IRI to refer to an external source, such as a web API. Second, a reference formulation, which specifies the language used to access the values of the data source. For example, if the data source is a JSON file, an appropriate reference formulation would be JSON path, which is a query language for JSON data. Finally, a logical source contains an iterator, which specifies how to access specific values of the data source according to the reference formulation. RuleWork is a Java implementation of the Datalog reasoner vlog reasoner. It combines a column-based memory layout with optimization methods that avoid redundant inferences, resulting in high efficiency in terms of memory usage and speed. On top is a virtual knowledge graph system that supports mapping schemas expressed in R2RML, a predecessor of RML, or their internal language OBDA, as well as lightweight ontologies expressed in OWL to rewrite SQL and Sparkle queries. Now, RML mapping rules can be hard to define, and any syntax errors will very likely not result in a successful integration. Because of this, we provide a graphical interface that can guide users through the entire process. To successfully use this system, we expect the user to be familiar with semantic web technologies, namely OWL to define ontologies, RDF triples and graphs, Sparkle as a query language, and of course RML. In the first tab, you can add your ontology file. The text box here will show the contents of the uploaded ontology, but it is read-only. The second tab is where the user uploads their local files and defines their mapping rules in RML. Uploaded files will be displayed in this box. The user can then click on the boxes for each file, which will show the name and the contents of the file. We currently support CSV, TSV, JSON, XML, and RDF in all standard formats. We provide a form that allows users to define RML rules in a more intuitive manner. There are input fields for all of the main components of a mapping rule, such as text fields and drop boxes to choose the type of values to generate. Alternatively, the user can upload an existing RML file. This is especially useful because the mapping rules can be reused, making the process easier in subsequent iterations. The graphic interface will show the uploaded RML file, where each triple map will be encased in a square box. By clicking on the box for a triple map, the relevant fields will be filled in a form below. We can then edit the fields by changing the text values, or whether it follows a URI template, or references a value in a source, such as a column name in a CSV file. You may notice some boxes are colored gray. This means that the triple map is missing a corresponding local file. This is because of security reasons. We cannot directly attach a local file from the user's computer into this form. Instead, the user must select one of their previously uploaded files from this drop-down menu and attach them to the triple map. Then update the mapping. This will turn it green, which means it's now ready. In the last tab, the user can provide a query to the system by typing a Sparkle query in this text box or by uploading a file containing a Sparkle query. In the case where the user wants to generate new data, this step is optional. Finally, the user can select whether to materialize new data or rewrite and answer the query in this drop-down menu. Then, by clicking on the corresponding button, the appropriate system will be called, and after a short wait, will display the results of the request. The main takeaways you should have of this presentation are first, that integrating various heterogeneous sources doesn't have to be hard. You can have a unified system that already contains the state-of-the-art technologies for this task. This then means that, second, you can have access to more data than ever because you're no longer limited by the structure of the data and can thus improve your business processes. Finally, by isolating the prerequisite knowledge to a single mapping language, RML, the learning curve is much less steep, and domain experts can save time and focus more on their area of expertise. For further information on the project, please visit our website at www.opcast-project.eu. For further information on the technologies employed in this plugin, please visit their respective websites. And if you want to get involved, you may request a tailored demo for your use case or participate in any ongoing pilots. By doing any of the above, you can make sure you will be at the forefront of data revolution. Thank you for your time.